Number 2, for t is greater than or equal to 0, a particle is moving along a curve so that its position at time t is x of t, y of t. At time t equals 2, the particle is at position 1, 5. It is known that dx dt is equal to the square root of 2 plus t over e to the t, and dy dt is equal to sine squared t. Part A, is the horizontal movement of the particle to the left or to the right at time t equals 2. Explain your answer and find the slope of the path of the particle at time t equals 2. So 3 different things going on in here. First of all, if we're talking about horizontal movement, we're talking about the x. And if I want to know how it's moving, I'm going to look at the velocity. So I need to find out what's happening with the velocity at time t equals 2. So I'm going to be finding dx dt at t equals 2. So I'm going to have the square root of 2 plus 2 over e to the 2. And if I were to type that in my calculator, well, I don't think I have an answer with it typed in my calculator. I get 2 over e squared. This is definitely a positive answer. And since this is a positive answer, the particle is going to be moving to the right. So I'm going to say the particle is moving right because dx dt is positive at t equals 2. Okay, the next part of this, I did explain my answer, so found it. And then find the slope of the path of the particle at time t equals 2. So all I need to do to find the slope of the path of the particle at time t equals 2, they're actually asking me on this one for dy dx. So I know I need to find that it's going to be sine squared t, it's dy dt over dx dt. And then once again, we're finding it at time t equals 2. So I'll do sine squared 2 over square root of 2 plus 2 over e to the 2. And when we do that, we should get 1 point, no, we should not. We should get 3.055. Okay, so this problem was worth 3 points. If we said it was moving to the right with a reason, we'd get a point. If we found dy dx was equal to dy dt over dx dt, we'd get a point, and then we'd get a point for the correct answer. So that was worth 3 points. All right, part B. Find the x-coordinate of the particle's position at time t equals 4. So what we are going to do, this is how fast the particle is moving. We're only, again, considering this part right here. And I noticed that basically if we want to find position and we're at velocity or at the derivative, we're going to need to take the integral. However, so I'm going to write the integral down here. Okay, the only problem is if we were to take this by hand, we are going to be stuck. So we need some limits on this because we're going to get to use our calculator to do this. So for sure, I want 4 in there. The only other time we know stuff happening is at time equals 2. The particle is at position 1, 5. So we are going to go ahead and put a 2 in there. So this will tell us how the particle moved from time equals 2 to time equals 4. And when we do that, I believe the answer is going to be 0.253. So that's how much it's moved from time 2 to time 4. We know that at time 2 it started at an x value of 1, so I get to add 1 to my answer. So the x-coordinate of the particle's position is going to be 1.253. And that would have been worth 2 points. If we had the integral set up, we'd get a point, and if we got the right answer, we'd also get a point. Okay, part C. Find the speed of the particle at time t equals 4, and then find the acceleration vector of the particle at time t equals 4. Okay, speed, if you recall, is the square root of x prime of t squared plus y prime of t squared. So all I need to do in this one, we know it's t equals 4. All we need to do is actually plug 4 into both of our derivatives. So we're going to have the square root of 4 plus 2 over e to the 4 squared plus sine squared of 4 squared. And when we do that, we should get an answer of 0.575. And then we do need an acceleration vector. Well, acceleration is the derivative of velocity, and dx dt and dy dt would be velocity. So we're just going to take the derivative of this. So we're going to take actually the, how we want to write this, second derivative of position And so really we're taking the derivative of each of these, and when we're taking the derivative of each of these, we'll actually do math 8, excuse me, for those, because to get those by hand would just be kind of a pain in the rear since we don't need to do them by hand. And when we do this, if you plugged the math 8 of this one and at 4, you're going to get negative 0.041. And then if you were to plug math 8 at 4 of the y equation, we'd get 0.989. So that is the acceleration vector. That was worth 2 points. We'd get 1 point for the speed and 1 point for the acceleration. And then part D, find the distance traveled by the particle from t equals 2 to t equals 4. Well, if you recall distance traveled, we also have a formula. It's the same as the arc length formula. We're going from 2 to 4, and it's going to be the square root. It's going to look just like the speed. However, we'll keep it general. So we'll have the square root of t plus 2 over e to the t squared. We don't actually have to put numbers in this time because we're going to let our integral do that for us. And then we'll have sine squared of t squared dt, and then we'll use math 9 for this. And when we do that, we should get an answer of 0.651. And that was worth 2 points, 1 for the integral setup and 1 for the correct answer.